All right, so we're going to talk about systems of equations today, and we're going to learn how to put those systems into a matrix. A lot of times when we have systems that are bigger than just x and y variables, we have x, y, and z, or sometimes we'll have 5 variables or 15 variables, stuff that just gets out of control that we can't handle as human beings. We have to sort of learn how to plug these things into computers and let the computer do the work for us, and that's what we're going to be doing today and learning how that works. But there's a whole language that goes along with matrices and how they work. Okay, so here's the gist. All right, I'm gonna start you off with an example and give you all the tools that you need. So all this stuff right here, right? This is a system. This is a system of linear equations. So here's our system, and what we need to learn how to do today is take a system and turn it into what's called an augmented matrix. Okay, so here's what it's going to look. So here's what it looks like. The framework for a matrix is going to have these big bars around it. So give yourself some big bars here, right? The framework for a matrix. So we're turning our system into, this is all going to be an augmented matrix. What's called an augmented matrix. Okay. What we're going to do is, the way it works is you look at the coefficients of the variables that you're given. So look at this x over here in the top left-hand corner. Right? What's the coefficient involved with that x? 1. Very good. So that's the number you write down. You write down a 1. So you're talking about the coefficient that's involved with that. So if I go straight across, right? If I go straight across, we're going to call those rows. Okay. So what's the next coefficient going straight across? 4. Very good. Okay. Then there's sometimes a little bar here in the middle, and that is going to be representative of the equal sign. And then on the other side of the equal sign, what do we have there? 14. We have a 14. Okay. So I got 1, 4, 14. Can we do the same thing with that second row right there? What would it be? 3, -2, and okay, good. Now let's talk about all the parts here. Okay. This part right here, this up and down, this 1 and the 3. That's going to represent your x column. Okay. This part right here, this 4 and this -2, that's going to represent your y column. And this part over here, the 14 and the 0, this is going to represent your answer column. Answer column. And the bars on the side represent matrix operations. And the way that we read matrices is we read them by columns and then by rows. All right. There's 2 different directions here. It's columns and rows. And sometimes people get this mixed up. Okay. So I'm going to highlight this in yellow. So this going across this way, this is a row. Okay. The first one is what we call row 1. So this is called row 1 and this is called row 2. And we start going, top to bottom, row 1, row 2. And we could have row 3, row 4, row 5, all the way down, right? As many rows as we have. And so left and right are called the rows. And then straight up and down are called the columns. So these are column 1, column 2, column 3, so on and so forth. So these are going to be called your columns. Columns, columns, and columns. Now, the way I remember this, right, is I think of like the Colosseum, and like those big towers out in front of the Colosseum, because Colosseum kind of sounds like column, straight up and down, right? And then rows, I think of like a dresser. Like my first row of my dresser has socks, second row has shirts, third row has pants. Think of dressers as rows and think of columns as straight up and down. That's how I do it. Okay? You guys okay with that part so far? Okay, so these are all the parts of it. And now each of these little things here, like this 1 right here and this 3, these are what we call entries. So we have a lot of words here. There are a lot of jargon or a lot of vocab that goes with matrix. You have to understand a matrix, what it looks like. There's this big brackets thing, right? You got to understand that there's rows, there's columns. You got to understand that there are entries inside these rows and columns, and you got to make sure that all your x columns line up, all your y columns line up, and then your answer columns line up on the other side. So that's sort of the introduction to what an augmented matrix is, all the parts of it. And then let's sort of generalize this. So in general, we're going to give ourselves a pretty big matrix here. And along the top, we're going to write down C1, C2, ... all the way to C sub n. And what do you think that's going to stand for going across there? Column 1, column 2, and then what? Column n. Yeah, however many columns you got, right? What do you think I'm going to write on the left-hand side here? Yeah, you got it. Row 1, row 2, dot, 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 row n. Or, sorry, we'll call it row m. Excuse me. Row m. All right? So, right here, this entry, this is going to be called A11. Okay? So, let's talk about this little part down here. This 1, this is called the index. So, what do you think the 1 stands for? Yeah, we do it. Row 1, column 1. You got it, okay? So this part here, if I did this one, this entry, it'd be A, row 1, column 2. So A12, correct? So what do you think this one would be way down here if I go dot, dot, dot all the way over? A what? 1, comma, very good, 1, comma, n. Now let's go down, okay? If I go down, this entry, I'm just calling A, this is going to be A21. Now why did it change to 21? Because it's the first... it's the second row, but still in the first column, right? So, yeah, it's important that the 2 comes before the 1. I'm going to define that in just a second. So if I go down even further, I'm going to have A, M, comma, 1, right? So now, can anybody then predict what would this be over here? A what? What would the index be for the M? Very good, nice job. M, and you put in the patterns together. So, what we've just learned is how to describe a matrix. How do we describe a matrix? So what we have is we have rows by columns matrix. So we always go row by column. So in this case, I have an M by N matrix. So this is how we define our matrix. And that's what that's also known as the order of a matrix. So you may hear stuff like, okay, I have a matrix of order 5 by 3. So you have to know what that means, right? If I have a matrix of order 5 by 3, that means I have 5 rows and I have 3 columns. And we're going to set those up, all right? So the little index there on the bottom is very important. It always goes row by column. And we always write them as an order of M column. So I'll move this up right there, and we'll unpause this for a second. All right, so we're gonna I'm gonna give you two. I'm gonna give you problem A and problem B. We're gonna write the augmented matrix and describe the order. So here's the first one. I'm gonna give you a system, and the system is gonna be this: 3x minus 4y is equal to -6, and 2x minus 3y is equal to -5. So I want you to transform that into an augmented matrix and describe the order. And here's the second one I'm going to give you. It's going to be 2x minus y plus z equals 0, x plus z minus 1 equals 0, and x plus 2y minus 8 equals 0. So go ahead, take a moment in time, work with a buddy, work with a friend, and turn both of these into an augmented matrix, and then describe the order. All right, who's got it? Give me the first one. Somebody give me the first one. A, let's talk about it. Then we got the augmented matrix for A. Nobody? What do you got? Give it to me. You didn't. What? You did B. Anybody do A? What'd you get, Lalo? 3. -4. Line. -6. Good. Then what? 2. -3. -5. Okay, great. Let me ask you, everybody, a few questions here. What do you call these things right here? What do you call them? Entries. Very good. Why is this little line there? Yeah, equal sign. Okay. What's the order of this matrix? It's what's the order? Remember, it's row by column, right? We go row by column. C-O-L-U-M-N. So how many rows does this thing have? This has 2 rows, correct? 2 rows. How many columns does it have? I know. I get that mixed up all the time, and it's hard to see which one's which. Okay. Give me the position of this entry. How would you describe where that is? What is it? It's row what? That's right. You could write this as A 2 comma what? There you go. Yeah, that is second row, second column. Okay. No, not really. All right. Okay, how would you describe this one? A1. No, not N. 3. A1, 3, right? First row, third column. Very good. Okay, let's do this one there. Now this one. Let's turn this into an augmented matrix. What's it going to be? Everybody just shout it out. 2. Negative 1. 1. Line. 0. Good. Next. 1. Ooh. Now that says X. What does that say? That says Z. So did anybody put a 0 here? Did anybody put a 1 here? And did anybody put a 1 here? Anybody do that? Oh, how come? How come? Oh, who sees it? Oh, why did I put a 0? Why, Sam, did you get this right? No, okay. Why did I do what I did? Why did I do that? Yeah, because remember, everything in this has to be what? That's my X column. This is my, and this is my answer column. Ooh, sweetness. Okay, good. We learned something there. Good. Kind of threw a wrench at you. All right, so let's get back to this. Okay, last row, what's it going to be? Okay, question, timeout. What did I do? This is the 1, right? That's my 1 there. So far, so good? Okay, this is a Z. Z's have to go here in the Z column, right? And that's a 1. I have no Y variable, which is why there's a 0 there. Does that make sense to you? Okay, so let me erase this and get these lines out of here so we can see. Okay, give me the last row. What's it going to look like? 1, 2, 0, 8. Okay, 1, 2, 0, 8. Very good. So again, you got to remember, this represents every X variable. This represents every Y. This represents every Z, and this represents your sort of your answers. What I call the answers or the constants. You can also call them the constants. So somebody out there, describe for me this entry. It's going to be A something something. What's it going to be? A2, 3. What does the 2 stand for? Row 2, column what? Column 3. Good. Someone give me the entire order. What's the order of this matrix? How many rows are there? 3. How many columns are there? So this is a 3 by 4 ordered matrix. Is this making sense to you guys? Okay. So you got to be careful when you are when you're trying to go from your system to your augmented matrix. You got to have all your columns lined up, X, Y, Z, and constants. And it's okay to move things around algebraically just like you would with a normal linear problem. Okay? How many people understand and see this now and understand why this is the answer for it? Okay, you guys good with that? Let's go the other way now. All right? Let's go the other way. What if I gave you this? What if I gave you, is that 5? 5, 2, 13, negative 3, 1, and negative 10. Okay, put this back into a system of linear equations. So let's go the other way. So let's take our matrix and let's put it back into a system. We've got to be able to go, both ways on this one. So how do I put that augmented matrix back into a system? What would it read? What would the first row be? 5x plus 2y equals 13. You got it. 5x plus 2y equals 13. Or some variable, right? It could be a and b, whatever it happens to be. And what would the next one be?
Negative 3x plus y
Equals negative 10. Good. So we can go both directions in this, right? All right. And then last one, what if I gave you this matrix? Take this matrix, put it back into a system of linear equations. How about 3, negative 1, 7? Let's go 202, 8, and let's go 0, 1, 1, 0. Okay, put that back into a... Okay, all right, anybody got it? How do I put this back into a system? What would it look like? 3x, okay, hold on, let me get there. 3x minus y minus z equals 7. Then I got what? 2x plus 2z. Very good. Equals 8. Good. Then what else you got? Y plus z equals 0. Good. Okay, I want you to notice all of my x's are still lined up. all of my Y's are still lined up, all of my Z's are still lined up, and all my answer columns are still lined up. So it's important that we keep things organized and vertically. Does that make sense?